All right, so now we're going to figure out the transformation that maps f of x equals cosecant of x onto y equals f of 2x. So here, this 2 is like a b value. So it's going to affect the period of my cosecant graph. Well, I know that the period of cosecant is the same as the period of sine, which is 2 pi. So my new period is going to be 2 pi divided by the b value, which is 2. So that'll be pi. And the transformation is that this is a horizontal shrink by a factor of 2. So we're taking the graph and we're compressing it down. So my period, I actually already did this. So this is going to be a/b. And then I want to sketch the graph from 0 to pi. Well, if they've told me to go from 0 to pi, I'm going to come down here and label this my pi. So then here I'd have pi over 2. And if I think about the graph of y equals, or f of x equals cosecant of x, well, that's 1 over sine of x. And then if I think about y equals f of 2x, that's going to be 1 over sine of 2x. So it's handy to know what sine of 2x looks like. Well, sine of 2x, I'm going to come in and put this in a lighter color blue. If I graphed sine of 2x, let's call this 1 and this -1, then I know sine starts at 0, and normally it finishes its cycle in 2 pi, but since I'm compressing it, it'll finish a cycle in pi, so I'll be back here, and then I'll be halfway at pi over 2. So I would come up to 1, down to -1. So that's what sine of 2x would look like. And I want to know that to help me draw 1 over sine of 2x, which was what I've been asked for, because I want y equals f of 2x, so 1 over sine of 2x. So I'm going to come in, put in my asymptotes anywhere there's a 0. So asymptote here, asymptote here, asymptote at pi. 1 divided by 1 is 1. As I get closer to 0, I get closer to infinity. Closer to 0 means closer to infinity when I divide by that value. And similarly, I have this one down here.